In just a few months, a tiny virus changed the entire world, shutting down cities, challenging science, and reshaping how we live. But what exactly is COVID-19, and how does it work inside the body? Join us as we explore the science behind this unprecedented global health event. Coronaviruses are a large family of viruses, common in both humans and animals. They can cause illnesses ranging from the common cold to more severe diseases. These viruses are named for the crown-like spikes on their surface. SARS-CoV-2, the virus responsible for COVID-19, emerged in late 2019. It is believed to have originated from an animal source, likely bats, before making the jump to humans. This type of transmission from animals to humans is known as a zoonotic spillover event. Understanding how SARS-CoV-2 spreads is crucial for public health. The primary mode of transmission is through respiratory droplets and aerosols. These are tiny particles released when an infected person coughs, sneezes, talks, or breathes. When these particles are inhaled by another person, the virus can enter their respiratory system. Close contact with an infected individual significantly increases the risk of transmission. This is why maintaining physical distance and wearing masks became vital public health measures. The virus can also spread through aerosols, which are even finer particles that can linger in the air for longer periods. This is particularly true in poorly ventilated indoor spaces. While less common, touching contaminated surfaces and then touching one's face can also lead to infection. Once SARS-CoV-2 enters the body, it targets specific cells, primarily in the respiratory tract. The virus uses its spike proteins to attach to AC2 receptors found on the surface of these cells. Think of it like a key fitting into a lock. After attachment, the virus injects its genetic material into the cell, hijacking the cell's machinery. It then forces the cell to produce more copies of the virus. These new viral particles then burst out, infecting neighboring cells and continuing the cycle. This viral replication can lead to a range of symptoms, from mild to severe. Common symptoms include fever, cough, fatigue, and loss of taste or smell. In more severe cases, the virus can cause pneumonia, acute respiratory distress syndrome, ARDS, and damage to other organs like the heart, kidneys, and brain. Our immune system is our body's defense mechanism against invaders like viruses. When SARS-CoV-2 enters the body, the immune system springs into action. It identifies the virus as a threat and begins to produce antibodies and T cells. Antibodies are proteins that can neutralize the virus, preventing it from infecting cells. T cells are specialized white blood cells that can directly kill infected cells. The strength and speed of this immune response can vary greatly among individuals. This variation explains why some people experience mild symptoms while others become severely ill. Factors like age, underlying health conditions, and genetic predispositions all play a role in how effectively the body fights back. A robust and timely immune response is key to recovery. The rapid development of COVID-19 vaccines was a monumental scientific achievement. Vaccines work by introducing a harmless part of the virus or its genetic code to the immune system. This teaches the body to recognize and fight the actual virus without causing illness. When exposed to the real virus, a vaccinated person's immune system can quickly mount a defense. This significantly reduces the risk of severe disease, hospitalization, and death. mRNA vaccines, like those from Pfizer and Moderna, were particularly groundbreaking, using genetic material to trigger an immune response. Beyond vaccines, various treatments were developed and repurposed to manage COVID-19. Antiviral medications, such as Paxlovid, help stop the virus from replicating in the body. Anti-inflammatory drugs, like corticosteroids, reduce the severe immune overreaction that can damage organs. Ongoing research continues to refine these treatments and explore new therapeutic avenues. The COVID-19 pandemic had an unprecedented global impact, reshaping nearly every aspect of life. Healthcare systems worldwide faced immense pressure, with hospitals overwhelmed and resources stretched thin. Frontline workers demonstrated incredible resilience and dedication. Governments implemented lockdowns, travel restrictions, and social distancing measures to curb the spread. These actions, while necessary, led to significant economic disruption, job losses, and changes in education. Remote work and online learning became the new norm for many. Beyond the immediate health crisis, the pandemic highlighted global inequalities and vulnerabilities. It underscored the interconnectedness of our world and the critical importance of international cooperation in addressing public health threats. The way we interact, work, and travel has been fundamentally altered. The COVID-19 pandemic was a profound learning experience for humanity. It demonstrated the incredible speed at which science can advance when faced with a global challenge. The rapid development of vaccines and diagnostic tests is a testament to human ingenuity and collaboration. It also highlighted the importance of robust public health infrastructure and clear communication. Investing in preparedness, surveillance, and equitable access to healthcare is crucial for future outbreaks. We learned the value of community, empathy, and collective action in times of crisis. The pandemic forced us to reevaluate our priorities and adapt to new ways of living. It underscored the delicate balance between individual freedoms and collective well-being. These lessons will undoubtedly shape our approach to health, science, and society for generations to come. COVID-19 was a challenge unlike any other, but it also showed the power of science, community, and resilience. The story of this pandemic is not just about a virus, it's about us. It's about our ability to innovate, adapt, and come together in the face of adversity. Understanding the science behind COVID-19 empowers us to make informed decisions and protect ourselves and our communities. Let's continue to support scientific research, promote public health initiatives, and foster a global community committed to well-being. Subscribe to our channel for more insights into health and science. Share this video to spread awareness, and join the conversation in the comments below. Your engagement helps us build a healthier, more informed future for everyone.